Welcome back CMA Math students. Today you'll be learning about systems of equations and systems of inequalities. The objective today is to learn to graph systems of inequalities, solve systems of equations using subtraction and substitution, and the different types of solutions.
Systems of equation can have three different solutions: one solution, no solution, and an infinite solution. A system of equation is a set of equations with multiple variables that are the same. To solve systems of equation, there are two methods that you'll learn how to do: the substitution method and the subtraction method.
To solve a system of equations using subtraction, using variable must be eliminated in order to solve for either x or y. To do so, you would multiply an equation to cancel out a variable. You are then left with one variable and a constant. Next, you would solve for x. After finding x, substitute in the missing variable and solve for y.
To solve a system of equation using substitution, first you need to isolate a variable. In this case, y is isolated. Next, you need to substitute an equation into the other. The equation to the right shows 5x minus 4y is equal to negative 3, where y is substituted by negative 3x plus 5. After doing so, solve for the missing variable. To find the other missing variable, plug in a variable that has been found to find y in this case.
When solving systems of equations, there are three different possible solutions. An equation with no solution can be seen as 0 equals 13, or parallel lines when graphed. An infinite solution when graphed shows just one line and is seen as 0 equals 0. If a system of equations has only one solution, this is when its lines intersect on a graph and x or y equal a number.
Systems of inequalities are a set of inequalities that place constraints on a graph that tell you what points are a solution on the graph. If the points do not fit within the constraints, then it is not a solution to the problem. Depending on if the inequality is greater than or less than, you shade the different sections of the graph accordingly. For greater than, you shade the greater portion of the graph. For less than, you shade the lower portion of the graph.
When a line has constraints, a point must fit those constraints. Otherwise, the point is not a solution to the inequality. The first constraint, 10 is greater than or equal to x plus y, means that the sum of x and y have to be less than or equal to 10. The second constraint, x is greater than 0, means that the point x must be greater than or equal to 0. The final constraint, y is greater than 0, means that the y point must be greater than or equal to 0.
The first constraint, 12 is greater than or equal to x plus y, means that the sum of the two variables must be greater than or equal to 12. The second constraint, x is greater than or equal to 0, means that the x value on the point must be greater than or equal to 0. The third constraint, y is greater than or equal to 0, means the y value on the point must be greater than or equal to 0.